Hello class, and this is the first series of online lectures that we'll be doing. Some of you have already seen this subject, other of you we did not get this in class, so we'll just go ahead and cover this right now. Today we're going to be dealing with implicit differentiation. And so the thing to remember about implicit differentiation is this is just a continuation of the chain rule, but we're going to be specifically looking at the case where y is a function of x, and so that's what we have to keep in mind. So when we take the derivative with respect to x, we're going to have a y prime, and we'll have to apply the chain rule when appropriate. Okay, so let's bring our attention to this guy right here. We want to find y prime, where y prime equals dy dx. So what we do is we take the derivative of both sides, like so, and then we apply the derivative to everything on the left-hand side, because it's addition, you can go to each one. And so we take the derivative of y to the m with respect to x plus the derivative of x to the n with respect to x. And keep in mind, over here, the derivative of a constant is 0. Okay, so let's bring our attention over here. This one, we simply apply the power rule. So the n comes to the front, and then we decrease the exponent by 1. And so for ym, we take the derivative as we normally would, m times y, raised to the m minus 1, and then there's the next step where we have to include the derivative of y, because we don't exactly know what y is. But we do know that y is a function of x, so we have to apply the chain rule here. And so the next step is to solve the function for y prime. And so, first you move this guy over. Like this. And then you simply, there we go. Sorry about that. And then don't forget the y prime. Got a little carried away there. And we divide through. And so y prime is negative n times x to the n minus 1 divided by m times y to the m minus 1. And there we go. That's it. That's y prime. Now sometimes we might ask you to solve the original equation for y and plug it in. If that's what we're looking for, we'll be specific in that case. For right now, I think it's okay to just leave it like this. Go and box that like that, and there we go. Alright, so let's take a look at this guy right here. Now we're going to apply the derivative to both sides of this equation, and so that we have the derivative of this first guy here, well, that's going to be 2x divided by 4. Right? No, we're just applying the power rule to this guy. And we're not putting an x prime because we are taking the derivative with respect to x. That's the important thing to remember. Now we're dealing with y here, and we are taking the derivative of y with respect to x, and y is a function of x. Those are the important things to keep in mind. So we have 2y times y prime, divide that by 9. Now on the right hand side, we're going to divide that 1. That 1 is a constant, and so the derivative of a constant is just 0. Next step, we're going to go ahead and solve for y prime. Before we do that, we know we've got a couple of things here. 2 over 4, well, that's going to leave us with a 2 in the bottom. 2 over 9, that's just going to be what it is. And so let's go ahead and bring this x over 2 over. So we have negative 2y, y prime, divided by 9 equals x over 2 negative. Okay. Now we simply multiply through by the inverse of this guy. So this is going to end up looking like this. X over 2, and then we have 9 over 2y. And note that the negative here canceled with a negative here. Alright. Alright, and let's go ahead and reduce this down a little bit. So we have, let's go and keep using the red. 9x over 4y. Alright, and we can solve the original equation for y. So let's go ahead and do that. Let's go ahead and solve this guy for y, and then we're going to plug that in right here for y. So that way we get y prime strictly as a function of x. Okay. So over here, all we do, we're solving for y, so we get y squared over 9, don't forget the negative, and that equals negative x squared over 4. And then we just go ahead and multiply by negative 9 and take the square root. And so we end up with y equals 9 times 1 minus x squared over 4, and we're putting a square root over that whole thing. Okay. And we can reduce this down just a little bit. Square root of 9 is clearly 3. We have 3 here. And we have the square root of 1 minus x squared over 4. So we're going to go ahead and take this amount right here, and we're going to plug it right in. So we have 4 times 3 times the square root of 1 minus x squared over 4. And so notice we have the 3 goes into the 9, and so we'll be left with a 3 up top. And so we can simply write y prime as 3x over 4 times the square root of 1 minus x squared over 4, and bring that all the way over. Alright, there we go, that's it. Okay, so we've got 3 problems here. I strongly recommend you press the pause button on this video and try and solving these on your own before looking ahead to the solution, but let's go ahead and run through these. Alright, we're using implicit differentiation, and we're going to try and find y prime. Note, it's a little difficult to separate the x and y in this one, so we're just going to solve it for y prime. So we take the derivative of both sides. I'm going to go ahead and zoom in on here. Okay, so we've got 2x, because that's the derivative of that guy. Okay, and now we're looking at this guy. We're going to take the derivative of negative 4xy. Notice that we use the product rule. Let me go ahead and factor that constant out. And so the derivative of x is simply 1, so 1 times y. And then plus x times the derivative of y, which is y prime. Okay, and there we go, that's it. That's the derivative of negative 4 times x times y. Now we're looking at that guy. And so we're going to go ahead and take the derivative here. And so that's going to be plus 2y y prime. And then for here, of course, that derivative is just 0. So So now we're going to go ahead and take the derivative, not take the derivative, but we're going to find y prime, so we're just going to solve for y prime. That is right here and right here. We notice we have a y prime, so let's go ahead and work through this one. And so here you see we've gone ahead and distribute this -4, and now all we have to do is solve for y prime. So we're going to just simply grab this guy here and send him on over. Alright, so you see we've moved this guy over. Notice we have a negative sign here, and we've also factored out the y prime, and so now all we have to do is divide through. So let me go ahead and make room for the next problem by just shifting this over. And so we have, alright, so you see that we've moved this over, and we've also factored out the y prime right there. And so let's go ahead and move this on over to give ourselves some space. For this next problem here, dividing through, we get y prime equals negative. Let's go ahead and just distribute this negative up here, 2x plus 4y. And so we're dividing by this amount right here. So we have negative 4xy plus 2y, and there we go. That's it. That's the answer right there. Alright, now we do the next one, and you see that right there that's going to be an example of the quotient rule. And so take the derivative of the top, that's 2x, and then we multiply that by the bottom here, like so, and then we subtract the top times the derivative of the bottom here. And so that's going to be 1 plus y prime. Okay, and then on the right hand side we've got 2y, y prime, and then of course the derivative of 1 is simply 0. Okay. Now at this point we're going to get everything that has a y prime on the left hand side of the equation and everything that does not have a y prime onto the right hand side of the equation. Alright, and here you see we've distributed the x squared to both these guys. We have a y prime here, so we just got to move all the y primes to the left, and everything that's not a y prime, such as this quantity here, we're going to move over to the right. Alright, and so I've kept the blue highlight so you can kind of easily see how that got moved over, and now all we have to do is divide everything in front of y prime and we'll have an answer. And here's our answer. You may notice that I took the negatives that were here and here, pulled out the -1, and placed it right there. Now for this last one, notice that we've got a product rule situation going on when we take the derivative of both sides. And so when we do that, we get derivative of x, that's going to be 1. So we have 1 times sine y plus x times the derivative of sine y, which is cosine y. And don't forget, very important, y prime right there. Okay, and since we know we're coming back to it, let's throw a highlight on there. Okay, and so plus, again, we're going to be applying the product rule in that guy right there. So derivative of y is simply y prime, where y prime equals dy dx. And so multiply that by the other guy, and then plus y times the derivative of sine x, which is simply cosine x. Okay, and then the right hand side will simply be 0, of course. And so now note, I've got sine y here, y cosine x. Neither of those guys have a y prime associated with them, so they get moved over to the right. And we're going to factor y prime out of these two guys right here. And this is what we have. We divide everything by what's in front of the y prime, and so we have this guy right here. And there we go. That's it. This is the final answer. Okay, so now we're going to go on further down, and we'll be looking at some inverse functions. First, let's focus on the inverse sine. Note that in order to get rid of the inverse, we simply take the function that it's an inverse of, and that would be sine. So we take sine of both sides. And so we have sine y equals x. And now we take the derivative of both sides. And so dx, of course, it's going to end up being 1. And on the right-hand side, we've got the derivative of sine y per dx. And so this ends up becoming 1 equals, cosine y times y prime. And then we solve for y prime, simply dividing through by cosine. And we get 1 over cosine y. Now we want to get y prime in terms of x. Fortunately, we have a way around this with the Pythagorean identity. And so don't forget, this is the Pythagorean identity, cosine squared y plus sine squared y equals 1. And so we want to get this in terms of sine, because if we get it in terms of sine, we'll have everything in terms of x. So we have cosine y equals the square root of 1 minus sine squared y. And usually that would be positive or negative, but we're just going to take the positive sign. And so we're going to go ahead and write this in. 1 over the square root of 1 minus sine squared y. And what do we have here? But we got sine of y, and sine of y is here, so anywhere we have sine of y, we can put in x. So we have 1 over the square root of 1 minus x squared. Alright, now for the inverse cosine, it's almost the same steps. I'm going to get these in both the same frame. I'm going to go through this a little bit more quickly. So this becomes cosine y equals x. Take the derivative of both sides to get this one right here. And then when you take the derivative of both sides, you get 1 equals negative sine y times y prime. Solve for y prime. And you get this guy right here. Note we've got a sine y, and we want to get sine y in terms of cosine y. And so we're going to go ahead and use the Pythagorean identity to our rescue again. Right here. And so we plug that in. To get this right here. And when you do that, we note that, hey, cosine y, that's the same thing as we have here, so we can replace it with x. And so we get 1 over negative the square root of 1 minus x squared. And there we go, that's it. That's the formula for the inverse cosine. Alright, so I recommend you putting on pause, try solving these on your own before looking at the solution. So notice this one is a simple product rule. And so we look at the derivative of this guy first. Derivative of that guy is going to be 1. So when we do the derivative, f prime x equals 1 times the inverse sine of x plus x times the derivative of this guy, which we already saw is going to be 1 over the square root of 1 minus x squared. And we can write this a little bit more neatly as follows. The inverse sine of x plus x over the square root of 1 minus x squared. And there we go, that's it. There's our answer for that one. So we notice this one is an example of the chain rule. And so we're just going to treat e to the x as our u and just take the derivative of the inverse cosine. Let's go ahead and actually do our normal it like this. If you want to use a shortcut, you can. But for right now, let's go ahead and just write out all the steps in case anyone's still struggling with this. It has been a crazy couple of weeks. Okay, so now we find f prime of u. And so for f prime of u, we simply write -1 over square root of 1 minus u squared. And then we got our u prime right here. And so don't forget, for the chain rule states that f prime of x equals f prime of u times u prime. Okay, so we plug everything in, and we will get the following. F prime of u is e to the x. We're going to go and throw that up top. And in the bottom, we're going to be plugging in our u, which is e to the x. So we've got the square root of 1 minus e to the x squared, which makes it 2x. Now let me throw some highlights in there to make it a little bit more clear. Oh, sorry, wrong color. Well, I'll edit that. Alright, so this is here, and that one's there. And there we go, that's it, that's the answer. Last one. We have sine x times the inverse sine of x. Notice this is a occasion for the product rule. And so we say f prime of x equals derivative of sine, which is cosine, and multiplied by sine inverse of x, that is a dot by the way, plus sine x, and we're going to find the derivative of this guy. As we saw earlier, the derivative of the inverse sine is 1 over the square root of 1 minus x squared. So we're just going to go ahead and put that right there. There we go, that's it, that's the answer. Alright, so now we're going to go on down. We're going to find the derivatives for the inverse tan and the inverse cotangent functions. And these all follow about the same pattern, so I'm going to go ahead and go through these a lot more quickly. Take the tan of both sides, get this guy here. Take the derivative of both sides right here, and we get since 1 equals secant squared y. Secant squared y is the derivative of tan y. Don't forget the y prime here on the end, solving for y prime. Again, we've got secant, and we need to get it in terms of tan, so we're going to use the Pythagorean theorem to the rescue. Divide both sides by cosine squared. And when we do that, we get this guy right here. Note we've got the secant squared hanging out right there, so we're going to plug that in for this guy. And so we make this substitution in, and we note, hey, here we are, we've got tan y, and tan y is the same as x. So plug that in, and we get this. Pretty neat. And so here we write cotangent y equals x, take derivative of both to get cotangent y. It doesn't matter. Whatever. Take derivative of both sides to get this result right here. And now we solve for y prime. Noting again that we got cosecant squared. Cotangent's over here, so we're going to use the Pythagorean theorem one more time. This time we divide by sine squared instead. Get this result here. So we simply plug it in to here, and we get this guy plugged in, and we notice, what do we have here but a cotangent y, which is exactly what we want to get in x, to get this result right here, or get it in more standard form, where we write it like this. If you put x squared first or last, does not matter, but that's the way I like to write it to be consistent. Alright, so we've got these three examples here. I encourage you to try these on your own. I'm sorry that I didn't leave enough space on these, but I'll go ahead and work through these the best I can with the space I have provided. So in this one, we simply apply the product rule and the two formulas that we just derived to get this result. We could simplify this down, but I think this is good enough. We'll just leave it like this. And so for the next one, notice this is a chain rule problem, and we'll just be applying the derivative of cotangent, and we'll get the result right here, negative e to the x plus over 1 plus e to the 2x, where again e to the 2x is simply e to the x squared. Alright, and on this last one, note this is going to be a product rule problem, and so we work through this and we get this following result right here. And we could clean it up a little bit, but we're just going to leave it like this. Okay, so let's go on to the next part. And again, we take the secant of both sides, like so. Take the derivative of both sides, and we get 1 equals secant x tan x, or secant y tan y, sorry. Don't forget the y prime at the end. Solve for y prime, like so. Note that, hey, look at this secant y here. That is already an x. We plug that in, like so. And note we still have a tan y. We want to get the tan y in terms of secant so that we can substitute an x. And we use the Pythagorean theorem for this and divide through by cosine squared. And so we have this nice equation. All we got to do is solve for tan to plug it in, like so. So we plug that in and we get this guy here. And then we note, hey, secant y, that's the same thing as x. So we plug it in and get this result right here. Alright, now let's do the same thing for inverse cosecant. It's going to be largely the same pattern. So let's go ahead and run through it. Cosecant y equals x. Take the derivative of both sides, like so, and then evaluate to get this result. Solve for y prime to get that result. And note that, like we did before, we already have a cosecant y and a cosecant y, so we plug that x in, like so. And now we're going to have to use the Pythagorean theorem for this guy here, because we want to get cotangent in terms of cosecant, because then we'll have it in terms of x. We'll come back over to the Pythagorean theorem, this time dividing by sine squared. And then solving this guy for cotangent y to get this result. So cotangent y, we plug that in, and we get this result. And so here's our cosecant y. We replace that with an x, and we get the following right here. Alright, and that's it. That's the formula for secant, inverse secant, and inverse cosecant. Let's go ahead and use these to solve these problems. I encourage you to press the pause button and solve them on your own. Alright, so in this one we note that we had to use the product rule, and we simply applied the formulas that we derived earlier in the sheet. And on this one, note that we simply used the chain rule, where e to the x up here was simply the derivative of e to the x, and our u substitution went in here and right there. Note we can also simplify this a little bit. We can take this e to the x and cancel out with that e to the x, and we will get negative 1 over the square root of e to the x minus 1. There we go, that's it. That's the answer for that one. And on this one, note, we simply use the product rule, taking the derivative of this guy first, and then the derivative of this guy next, here and here. Not necessary to include the parentheses, I simply put them there so you can see the operations that were going on. Note we could simplify this one, and let's go ahead and simplify this one. Note we've got a secant x here, secant x there. We can go ahead and pull that out of both terms, and we will get secant x times tan x times the inverse secant of x plus 1 over x times the square root of x squared minus 1. And that's a good final answer right there. Okay, so that's a wrap for this handout. Note that we had a symmetry going for each of the different types of trig functions. The difference between cosine and sine was simply a negative sign. The same thing with inverse tan and inverse cotan, and what am I missing? Oh, I hit them all. I will be editing this. So, and then also further note that we use pretty much the same methodology, and that was using implicit differentiation to work through these problems. And this is something that we will continue to using as we progress further.